our last lesson of chapter 3 is still related to our topic of absolute value. In your learning target today, you can solve absolute value inequalities. That's what you're going to be able to do today. And hey, you also are going to be able to graph today. Inequality has to deal with graphing. Now, this is like the main abstract unit of this whole section. And absolute value themselves are pretty confusing. So if this is even the most difficult, well, we better watch out. Here's what we need to know about absolute value inequalities. Make sure that the absolute value sign is alone. That's always your top priority. Get the absolute value sign all by itself. Second, we create our cases. So really, it's the same thing we've been doing, except instead of an equal sign, we have an inequality sign. Okay? That's the only difference today. And remember, when you divide through by a negative with an inequality, you're going to need to flip it. So when you make your negative case, you're going to have to flip your inequality. When you make your negative case, you flip it. And then you solve both cases. Okay? So we make sure that it's alone. Create our cases. Then what do? Flip the second case and graph. Solve and graph. So make sure it's by itself. Create our cases. Flip the second case. Graph. Okay, got it. I can do it now. So the absolute value of 2x is bigger than or equal to 12. Is it alone? Yes, it is. There's nothing by the absolute value sign except the inequality. So I can make my cases. So I say 2x is bigger than or equal to 12, or, now I got to flip it with the negative case. 2x is less than or equal to negative 12. That's all, that has to deal with MD and Fing. Remember that? Anytime you multiply or divide by a negative or change signs, you have to flip that second case. So x is bigger than or equal to 6, yes? Do you agree? Mm-hmm. Or x is less than or equal to negative 6. And now we graph. I have a colored in circle at 6 going to the right. And they're not, even though I have the word or in here, sometimes it's going to turn to an and graph. That's why you're going to have to check it out to see how it goes. Or x is less than or equal to negative 6. Color it in, go to the left. So that is still an or graph. Okay, next one. Is my absolute value by itself?
Yes.
Yes. The absolute value sign is by itself. I'm not adding anything to it. I'm not multiplying anything to it. It's all by itself. So I create my cases. I say, I'm going to do it down here so I have more room. I'm going to say x minus 3 is less than 6. There's my positive. Now I'm going to do my negative case. X minus 3 is bigger than negative 6. What did I do with this second case? I flipped. Make sure you flip the second case. X is less than 9, or x is bigger than negative 3. Now this looks like an or. Let me see if I actually graph it like an or. X is less than 9 means a circle at 9 going to the left. Bigger than negative 3, a circle at negative 3 going to the right. What's going to happen? It turns into an and. Okay? Got it. So the main thing, you've done all this before. You've graphed, you've solved, you've made cases. The only thing you haven't done is made your second case where you have to flip an inequality. That's the only thing that's new today. You've done everything else. Okay. Let's see. This is having to get it alone first. I'm just telling you that it's a grouping symbol. It's like parentheses, absolute value. It's really important. But before you make your cases, you have to make sure it's alone. You already know that. We covered that yesterday. So let's do the first one. The absolute value of 2x minus 1 minus 3 is less than 4. What do I need to do first? Tell me. Yep, I need to add 3 first because it's not by itself. So I get the absolute value of 2x minus 1 is less than 7. Can I make my cases? Yes, because it's by itself. You have to make your cases. So I say 2x minus 1 is less than 7, or, I'm going to need room, I can tell. 2x minus 1, now what do I need to do with the inequality? Flip, is bigger than negative 7. Solve, 2x is less than 8, x is less than 4. Solve, 2x is bigger than negative 6, x is bigger than, what, negative 3. I can already tell this is going to turn into an and. You know why I know that? If I'm less than 4, I'm going this way. If I'm bigger than negative 3, I'm going this way. They're going to smash into each other. All right, next one. 3 times the absolute value of 4x plus 3 is bigger than 15. Is it by itself?
No.
What do I need to move? The 3. So I'm going to divide both sides by 3. And I get the absolute value of 4x plus 3 is bigger than Friday brain 5. Yeah, no, I'm losing my train of thought. Now can I make my cases? Yes, because the absolute value sign is by itself. So I'm going to say 4x plus 3 is bigger than 5, or 4x plus 3 is what? Smaller than negative 5. Nice. If you're feeling like you're going to remember to flip that inequality, you are beyond where I expect you to be right now. So that's really good, because it's hard. 4x is bigger than 2. X is bigger than it's not 2. Probably 30% of us are going to write 2 here. It's 1/2. 2 over 4, which is a half. Sure. I don't care. Or 4x is less than negative 8. X is less than negative 2. Let's analyze. Do we think this is an or an and? Or. Bigger than a half goes like this. Less than 2 goes like this. Opposite directions, they're an or. Yep. Oh yeah. I mean, I don't know which ones, but yeah, you'll have to graph today. The absolute value of 3x over 4 is bigger than 1? No, this is not an and. Because if you're bigger than a half, you go to the right. Bigger is to the right. If you're less than negative 2, you're going to be going to the left, so they're opposite ways.
Oh, I see.
Okay. So, what do I need to get rid of? Eli? How? Yes. Or, yeah. So I have that canceled that out. I have the absolute value of 3x is bigger than 4. Alex, give me a case. I mean, like this. that's a case. 2x minus 1 is less than this.
Oh,
So 3x is,
greater than 4.
or,
3x is smaller than -4.
nice. Okay. Solve both cases. X is bigger than 4/3, or x is less than -4/3. Analyze it a little bit more. Do we think it's going to be an and or an or? Let's see, bigger than 4/3, if I were to graph it, bigger than goes here,
4.
smaller than goes here, like that. So it looks like it's an or graph. Ah, look at all this. This is the last one we're going to do. Okay, Eli, what should I do first?
And multiply first.
I would.
Oh, I subtract 4 then.
Tatiana, what do you think I should do?
Subtract 4.
So now I have the absolute value of 4x minus 2 over 2 is less than 2.
Could you still get the same answer?
If you remember to times this by 2 too. But if you didn't times this by 2, then no, your answer is going to be wrong. Okay? Now times 2 times 2. Almost done. Absolute value of 4x minus 2 is less than 4. Now I need my cases, because it's all by itself. So case 1 is 4x minus 2 is less than 4. Case 2, 4x minus 2 is bigger than -4. And solve. 4x is smaller than 6. And solve. X is less than 6/4, which is 3/2. Okay, solve the other one. Look at all this algebra. Who would have thought we'd be doing all this in 8th grade? 4x is bigger than +2, -2, -2. -4 plus 2 is -2. X is bigger than -2/4, which is -1/2. Okay? Now imagine graphing it. 3/2 would be about right here, let's pretend. It's 1.5. 3/2 is 1.5. If I'm less than, I'm going this way. Bigger than 1/2, -1/2. I'm going this way. They smush together. That's an and graph. Okay?